Hello there, we are Adi. And we are Modern Construction Company. We are beyond.
Beyond what, you ask? For us, green is more than just the color and the movement. It's beyond. It's a commitment to further invest in ESG and surely to reduce carbon emissions from our breakthrough.
It's planting not just that small tree. But 1,000 actions of green in different locations.
Amazing, right? Yes, we are Adi and we are beyond.
Setiap gerak kami adalah fondasi untuk menjadi perusahaan energi kelas dunia yang peduli lingkungan. Kami memasuki era digitalisasi dan elektrifikasi untuk meningkatkan kapasitas produksi dan efisiensi. Kami tak sekedar mengeksplorasi, tapi juga peduli pada masa depan planet bumi. Kami persembahkan sebuah warisan energi tanpa henti untuk negeri ini.
Setiap hari kita butuh energi. Energi yang menggerakkan kita, energi yang menghasilkan kebaikan, energi untuk terus berkarya dan berinovasi. Dengan bertumbuhnya kebutuhan energi Indonesia, ExxonMobil mendukung Indonesia untuk memaksimalkan produksi energi dan membangkitkan pertumbuhan ekonomi. Kami memproduksi energi dan mengantarkannya ke berbagai penjuru negeri. ExxonMobil bangga menjadi mitra Indonesia. Bersama Indonesia, kita mengembangkan minyak dan gas bumi dan berkontribusi kepada perkembangan negeri selama lebih dari 124 tahun. Pada tahun 2001, kami berhasil menemukan cadangan minyak di lapangan Banyu Urip dan ditunjuk sebagai operator blok cepu di bawah pelaksanaan pengelolaan K3S oleh SKK Migas. Hingga tahun 2022, blok cepu telah menghasilkan produksi kumulatif lebih dari 550 juta barel. Saat ini, blok cepu menjadi salah satu produsen minyak terbesar di Indonesia. Ini adalah perwujudan komitmen kami, guna memenuhi kebutuhan energi nasional dari sektor hulu migas. ExxonMobil juga hadir melumasi mobilitas masyarakat Indonesia dengan menyediakan berbagai produk seperti BBM berkualitas tinggi, produk pelumas, dan petrokimia berkualitas yang bermanfaat bagi kehidupan kita setiap hari. Tidak hanya itu, ExxonMobil juga mendukung program pemberdayaan masyarakat yang berfokus pada kesehatan, pendidikan, dan pengembangan ekonomi. Program kesehatan ExxonMobil dilandasi keyakinan bahwa kesehatan yang baik dapat membuka peluang, memunculkan prestasi, dan tumbuh kembang yang optimal. Selain itu, kami percaya pendidikan merupakan penggerak kemajuan bangsa. Kami terus mendukung program pendidikan yang membantu efektivitas proses belajar mengajar. Program pendidikan kami menyentuh para guru sekaligus peserta didik. Di bidang pengembangan ekonomi, berbagai program berfokus pada peningkatan kesejahteraan masyarakat. Di antaranya, kami mengembangkan program biogas sebagai energi alternatif guna mewujudkan desa mandiri energi. Efek berganda program ini bermanfaat bagi perekonomian keluarga. ExxonMobil di Indonesia berkomitmen untuk terus mendukung pertumbuhan ekonomi Indonesia dan tercapainya masa depan rendah karbon di Indonesia, dan juga turut berkontribusi langsung bagi masyarakat Indonesia. Bersama, kita bisa wujudkan masa depan yang lebih cerah dan beragam inovasi agar kita bisa terus menikmati energi penuh harapan. Inilah energi ExxonMobil dari Indonesia untuk Indonesia.
Embracing opportunities, nurturing hopes. We are undoubtedly part of it. Managing all the untapped potentials, preserving them and turning them into compounded effects as a heritage for the future. We are an inseparable part of this country, Indonesia. A nation built on noble culture and the spirit of mutual cooperation. Values having led us, Energi Mega Persada, or EMP, to become one of the leading and largest public companies in the upstream oil and gas industry in Indonesia. With the expertise we possess, coupled with innovative application of modern technology, EMP is now a primary supplier of the national energy needs, especially in Java, Sumatra, and Sulawesi. Starting our business over 2 decades ago, the pace of EMP has been unstoppable, successfully managing 13 exploration and production operational areas. One of them is located in Mozambique, South Africa, and the other 12 are in Indonesia.
Indonesia lies in the convergence among 3 tectonic plates. This motherland is blessed with an amazing geological landscape, located along the string of volcanoes known as Ring of Fire, making Indonesia admired for its earth resources, yet anticipated for its geological disaster threats. Learning the characteristics of Indonesia's geological resources and hazards need to be supported with competent basic geological knowledge. Universitas Gadjah Mada Yogyakarta, through Department of Geological Engineering since its early establishment as an education and research media, study on structure, composition up to physical properties of this motherland, even the world. Established since August 1959, becoming part of Faculty of Engineering Universitas Gadjah Mada, Department of Geological Engineering has been one of the windows of education which contributes to create this country's best researchers and geologists. Carrying on the vision to become a leading center in applied geology, Geological Engineering UGM provides learnings, researches, and international qualification lecturers. Located in the complex of Faculty of Engineering Universitas Gadjah Mada, this campus is supported with comprehensive and modern education facilities. Supported also with Geological Field Station in Bayam, Klaten. Delivers of dynamic teaching-learning interaction. Geological Engineering UGM, recognized for its continuous achievements, national and international. Every year, professional graduates are born. Geological Engineering UGM creates independent and creative researchers and geologists, professional who is able to cooperate and grow in global competition. The strengthening of sustainable network, quality recognition by national and international accreditation agencies, open the opportunities to cooperate with government institutions, private companies, renowned universities abroad, or even global workforce. Existing and potential cooperations open the opportunity to hold international graduate programs and to take part in double degree programs at partners institutions. This is the department that oversees quality and integrity. This is the learning space where professional graduates are born. Graduates that bring the value of Pancasila. This is a place where independent, creative, and excellent human resources are born. This is Geological Engineering Department, Universitas Gadjah Mada's dedicated to Indonesia.
Hello there, we are Adi. And we are Modern Construction Company. We are beyond.
Beyond what, you ask? For us, green is more than just the color and the movement. It's beyond. It's a commitment to further invest in ESG and surely to reduce carbon emissions from our breakthrough.
It's planting not just that small tree. But 1,000 actions of green in different locations.
Amazing, right? Yes, we are Adi and we are beyond.
Setiap gerak kami adalah fondasi untuk menjadi perusahaan energi kelas dunia yang peduli lingkungan. Kami memasuki era digitalisasi dan elektrifikasi untuk meningkatkan kapasitas produksi dan efisiensi. Kami tak sekedar mengeksplorasi, tapi juga peduli pada masa depan planet bumi. Kami persembahkan sebuah warisan energi tanpa henti untuk negeri ini.
Setiap hari kita butuh energi. Energi yang menggerakkan kita, energi yang menghasilkan kebaikan, energi untuk terus berkarya dan berinovasi. Dengan bertumbuhnya kebutuhan energi Indonesia, ExxonMobil mendukung Indonesia untuk memaksimalkan produksi energi dan membangkitkan pertumbuhan ekonomi. Kami memproduksi energi dan mengantarkannya ke berbagai penjuru negeri. ExxonMobil bangga menjadi mitra Indonesia. Bersama Indonesia, kita mengembangkan minyak dan gas bumi dan berkontribusi kepada perkembangan negeri selama lebih dari 124 tahun. Pada tahun 2001, kami berhasil menemukan cadangan minyak di lapangan Banyu Urip dan ditunjuk sebagai operator blok cepu di bawah pelaksanaan pengelolaan K3S oleh SKK Migas. Hingga tahun 2022, blok cepu telah menghasilkan produksi kumulatif lebih dari 550 juta barel. Saat ini, blok cepu menjadi salah satu produsen minyak terbesar di Indonesia. Ini adalah perwujudan komitmen kami, guna memenuhi kebutuhan energi nasional dari sektor hulu migas. ExxonMobil juga hadir melumasi mobilitas masyarakat Indonesia dengan menyediakan berbagai produk seperti BBM berkualitas tinggi, produk pelumas, dan petrokimia berkualitas yang bermanfaat bagi kehidupan kita setiap hari. Tidak hanya itu, ExxonMobil juga mendukung program pemberdayaan masyarakat yang berfokus pada kesehatan, pendidikan, dan pengembangan ekonomi. Program kesehatan ExxonMobil dilandasi keyakinan bahwa kesehatan yang baik dapat membuka peluang, memunculkan prestasi, dan tumbuh kembang yang optimal. Selain itu, kami percaya pendidikan merupakan penggerak kemajuan bangsa. Kami terus mendukung program pendidikan yang membantu efektivitas proses belajar mengajar. Program pendidikan kami menyentuh para guru sekaligus peserta didik. Di bidang pengembangan ekonomi, berbagai program berfokus pada peningkatan kesejahteraan masyarakat. Di antaranya, kami mengembangkan program biogas sebagai energi alternatif guna mewujudkan desa mandiri energi. Efek berganda program ini bermanfaat bagi perekonomian keluarga. ExxonMobil di Indonesia berkomitmen untuk terus mendukung pertumbuhan ekonomi Indonesia dan tercapainya masa depan rendah karbon di Indonesia, dan juga turut berkontribusi langsung bagi masyarakat Indonesia. Bersama, kita bisa wujudkan masa depan yang lebih cerah dan beragam inovasi agar kita bisa terus menikmati energi penuh harapan. Inilah energi ExxonMobil dari Indonesia untuk Indonesia.
Embracing opportunities, nurturing hopes. We are undoubtedly part of it. Managing all the untapped potentials, preserving them and turning them into compounded effects as a heritage for the future. We are an inseparable part of this country, Indonesia. A nation built on noble culture and the spirit of mutual cooperation. Values having led us, Energi Mega Persona, or EMP, to become one of the leading and largest public companies in the upstream oil and gas industry in Indonesia. With the expertise we possess, coupled with innovative application of modern technology, EMP is now a primary supplier of the national energy needs, especially in Java, Sumatra, and Sulawesi. Starting our business over 2 decades ago, the pace of EMP has been unstoppable, successfully managing 13 exploration and production operational areas. One of them is located in Mozambique, South Africa, and the other 12 are in Indonesia.
Selamat datang di Gedung Prof. Ruseno, Fakultas Teknik Universitas Gadjah Mada. Gedung ini terdiri dari 11 lantai dengan pemanfaatan lantai 1 sebagai selasar, lantai 2 sebagai ruang administrasi, lantai 3 sebagai meeting room, dan lantai 4 hingga 11 sebagai ruang perkuliahan serta co-working space. Setiap lantai memiliki tangga utama dan 5 buah lift di sisi tengah, serta tangga dan lift darurat di sisi barat dan timur. Gedung ini juga memiliki fasilitas kedaruratan berupa petunjuk arah, smoke detector, alarm siaga, alat pemadam api ringan, hidran, serta area titik kumpul. Saat ini Anda berada di auditorium lantai 3 sayap selatan. Ruangan ini terdapat 2 pintu utama di sisi timur yang bisa digunakan sebagai pintu darurat serta 2 pintu darurat di sisi selatan. Untuk toilet berada di sebelah timur lantai ini. Saat ini tidak ada pelatihan keadaan darurat, sehingga apabila alarm tanda bahaya berbunyi atau terjadi guncangan, berarti itu adalah kejadian yang sebenarnya. Jangan panik dan ikuti petunjuk evakuasi sebagai berikut. Jika terjadi kebakaran, maka alarm siaga otomatis berbunyi. Hentikan aktivitas. Secara tertib silahkan keluar melalui pintu keluar yang berada di sisi timur. Belok kanan kemudian keluar gedung melalui tangga darurat. Apabila Anda duduk di belakang, Silahkan keluar menggunakan pintu darurat yang berada di sisi selatan, lalu turun menyusuri tangga darurat. Bawa barang seperlunya. Selama perjalanan keluar, lindungi kepala menggunakan tangan dan atur pernafasan. Jika Anda berjalan tepat di sisi railing tangga, maka berpeganganlah pada railing tangga. Jika Anda berada di tengah, maka berpeganganlah pada orang di samping Anda. Jika merasakan guncangan pada gedung, hentikan aktivitas dan segera berlindung di samping kursi. Tetap tenang dan tunggu sampai gempa berhenti. Secara tertib, silahkan keluar melalui pintu keluar yang berada di sisi timur. Belok kanan, kemudian keluar gedung melalui tangga darurat. Apabila Anda duduk di belakang, silahkan keluar menggunakan pintu darurat yang berada di sisi selatan, lalu turun menyusuri tangga darurat. Setelah berada di luar gedung, segera menuju ke titik kumpul. Hindari berada di bawah pohon atau di bawah tiang listrik. Jika mengalami luka, segera hubungi petugas kesehatan. Terima kasih atas perhatian yang diberikan. Selamat beraktivitas dan selalu utamakan keselamatan. Semoga Tuhan Yang Maha Kuasa selalu melindungi kita.
Good morning, ladies and gentlemen. Distinguished guests and our keynote speakers, and all participants in this room and also who join us at Zoom meeting. Welcome back to the 4th International Conference on Geological Engineering and Geoscience, ICGoES, in association with AUN SIDNET Regional Conference, Advancing Earth Sustainability Through Geoscience and Technology. Hosted by Geological Engineering Department Faculty of Engineering Universitas Gadjah Mada in cooperation with AUN SIDNET. We hope you had a productive day yesterday and will have a more insightful day today. Ladies and gentlemen, allow me to once again extend our gratitude to our long-term partner AUN SIDNET and our industry partners, PT Adikarya Tbk, PT Energi Mega Persadap Tbk, PT Bukit Asam, PT Solusi Bangun Indonesia Tbk, ExxonMobil, PT Geodipa Energi, PT Antam Tbk, PT Geodipa Energi, Groundwater Working Group, PT Brau Coal Energy Tbk, and Aqua. Thank you for making the ICGoES 2024 happens. We had successfully hosted a fruitful discussion on the current role of geosciences, geotechnology for sustainable future and hazard mitigation. And today we are going to discuss about strengthening the relationship between industry, government and academia in geosciences. In our house this morning, we will have Dr. Hedi Rahadian from Ministry of Public Works and Housing, and then we have also Mr. Johan Arif, General Manager Exploration Georesources. And ladies and gentlemen, please welcome to our ICGoES stage, Dr. Nugroho Imam Setiawan as the session moderator to present our keynote speakers and aid the panel discussion. The stage is yours, Dr. Nugroho.
Okay, good morning, ladies and gentlemen, students. Selamat pagi, Assalamualaikum warahmatullahi wabarakatuh. So, it is an honor to me to be a moderator in this panel discussions. And today is the second day of the ICGoES, and it's getting more interesting. And our topic discussions today will be strengthening the relationship between industry, government, and academia in geoscience. And in this panel discussion, we will have two panelists. Panelist number one, Dr. Hedi Rahadian. Dr. Hedi Rahadian will be joined with us online, so I have already see Dr. Hedi in the Zoom meeting. Yeah, please give applause to Dr. Hedi Rahadian. And second panelist will be Mr. Johan Arif. So Mr. Johan Arif, could you join with me in the stage? So give applause to Mr. Johan Arif. Okay, before we start this panel discussion, I would like to introduce our panelists today. So the first panelist will be Dr. Insinyur Hedi Rahadian, MSc. He currently serves as principal expert in road and bridge management at the Secretariat of the Directorate General of Highway, Ministry of Public Works and Housing. He holds a bachelor degree in civil engineering from Bandung Institute of Technology, and then master degree in building and highway engineering, and PhD in the same field, both from the University of Strathclyde in Scotland. So in recognition of his exemplary service, he was awarded the Anugerah ASN Teladan in 2021 by Menpan RB. And the second panelist, together with me in the stage, Mr. Johan Arif, ST MSc, has distinguished background in geology and mining from Bandung Institute of Technology and Master of Economics Geology from James Cook University. His extensive career includes a significant tenure in Newmont Mining Corporation from 1996 to 2014, where he served as a senior exploration geologist and superintendent of mine geology. And since 2014, he has been with J Resources Nusantara, where he has advanced to the role of Head of Exploration and General Manager of Brownfield Exploration. His experience reflects a deep expertise in both exploration and mine geology, showcasing a leadership and strategic ability in the mining industry. So those background of our two panelists that, it will be very interesting for us to the discussion. And the first opportunity I will give to Dr. Hedi Rahadian. So good morning, Dr. Hedi.
Good morning, Pak Nugroho and Pak Johan for this conference. Thank you.
Okay, thank you for joining with us and give your insight about our topic today. And if you ready, maybe you can start the presentation.
Okay, thank you. So thank you, moderator. Allow me to share the screen. Okay, I don't know if you already see the presentation. So thank you very much for inviting me to the very interesting conference, and I will be talking about the role of geology in infrastructure development. And my outline presentation, first I will talk about the vision of Indonesia and the infrastructure challenges and the business process. And I think also I'll mention about the geology of Indonesia with all of you mastering it. Also geological challenges, particularly in road infrastructure, and then the role of engineering geology, and then conclusion. Right. So I think all of you are already aware that we have a long-term vision on the growth of 2045, the vision of a golden era of Indonesia. And if we are talking about the pillars of growth, when I'm talking about infrastructure, we are talking about how we develop infrastructure stocks, which we are very loud right now, in terms of how we can integrate of the infrastructure to promote economic development. And also there is also issue about the quality, how to distribute the infrastructure stocks throughout this past archipelago. And we are talking to the future. I think the state instruments now related to infrastructure now developing what they call technocratic medium-term policy direction, 25 to 29. Technocratic means that it is purely based on the analytical scientific approach, but of course the implementation will be dependent on the policy of the new administration later on, which of course included the component of some intangible factors. So the main issue remains about the economic transformation, hilirisasi, downstreaming of our natural resources, also how we develop our human capital through innovation, capacity, and then research enhancement and labor productivity. This is where the area of Ministry of Public Works also focusing at. I'm talking specifically on the road infrastructures. Our road infrastructure stock is still low compared to our neighbor, and we are talking about the road connectivity. In Indonesia, we have about nearly 500,000 kilometers of roads, including the toll road, what we call national road, provincial road, kabupaten, and city roads. And this is relatively low compared to other countries. So the number of the length of the roads in, for example, for comparison, Kazakhstan is maybe 4 times or 5 times than Indonesia, which I mean in the same level of development. So our road stocks is quite low. And then the impact of this condition is that the travel time. Travel time is the main indicator, the ultimate indicator if we are talking about connectivity. So in Indonesia, we are now still in the order of 1.8 hours per 100 kilometers in the main trunk road, including toll road. So at the other side, for example, Malaysia, one of member of our peer groups is in the order of 1 hour per 100 kilometers. So the higher travel time, that means that the higher transport costs. Higher transport costs means higher logistic costs. And higher logistic cost means that our product is not competitive enough in the common market, international market. So this is our challenge, how we reduce The travel time now we are eyeing about 1.5 hour per 100 kilometers in the reasonable situation to make Indonesia competitive enough in terms of logistic costs. So this is our road networks, which is not so impressive. The road is very expensive to build and very expensive to maintain. And in every country, rich countries, poor countries, the need for road budget is problem. And in Indonesia, it is even harder to get a sufficient budget to maintain and to develop our road networks. If we see Indonesia, we are talking about connectivity. Of course, the road is not only the mode of transport we need, because we are archipelago, we are archipelago state, and the mode of transport should be multimode. As for rule of thumb, the short distance transport should be supported by roads. The medium distance transport should be supported by train, and long distance transport should be supported by sea. But if we look at the structure of the transport in Indonesia, 90% still relying on roads. This is the complication because a lot of factors related to road transport, and this is very complex problems. Our homework to solve these issues. For example, now I think maybe 10 years ago there is a study from the World Bank that transporting cement from Padang to Jakarta is much more expensive than transporting cement from China to Jakarta. So this is our big issues, why our logistic cost is still high, because we need to make our transport system much more competitive in the future. So and then I'm talking about the business process. The business process, it is common business process on infrastructure. We start from the general planning. We are talking about a relationship between spatial planning and the connectivity. It needs, because there is interaction between land use and the need for transport. And I think our awareness on this issue is still low. For example, why we always have traffic jam? Because we don't have yet regulation on the land use. When we widen the road and then people build apartment and no control on how traffic generation due to this new building. In other countries, for example, the traffic generation is controlled. For example, we have a 7-meter wide of road. Then the maximum level of apartment, for example, is limited to, for example, 5 or 7. So this one, I think, a matter of understanding of the policymaker in the local government, still low in related to the interaction between land use and the need for transport. And then planning, programming, and then have the technical planning, design, and then final technical planning, and then some of pre-construction process, and acquisition, bidding, etc., and then construction stage, post-construction, operation and maintenance, and then evaluation, and then this normal management cycle. What stage engineering geology involved is mainly in the technical planning, and then also in the actually to some extent in the construction. This one, the scope or the depth of the technical analysis, technical survey, it depends on what stage we are in. For example, in the feasibility study, it is more on the assessment in terms of economic. So it should be in the reasonable time. Thus, it is difficult to have much more in-depth survey or analysis in this stage, because we still have to assess how we're going to execute it, in what size, or we go to the no-go option, for example. And then when we are talking about the technical, more technical aspect, and then more technical stage, finalization of technical stage, and then we need to have more in-depth data and analysis. This is the ideal one, but in reality, of course, there is some political pressure how to realize the project as soon as possible. And this one, I think you are already mastering it. Basically, we are in the disaster-prone areas. It is undeniable. And then we have many hazards to consider. Volcanic eruptions, rich geologic structures, and then hilly and mountainous areas, tropical soils, which differentiate us on how to treat our infrastructure, which is built on these soils, compared to the soils in the temperate climate. Because in the tropical areas, we have more a kind of chemical weathering, more dominant than physical weathering that we have in the temperate climate area. And then the issue of tropical soils, tropical sedimentary soils, tropical geology is our main issues, because sometimes people learn from the experience of engineering in the temperate climate countries, and then sometimes it's not fully applicable in Indonesia. So this is our challenge. And then these disaster-prone problems need more budget to mitigate. For example, in terms of earthquake design, we already several times updating our seismic standard design for building, for bridge, also for high embankment or cut. And then every time we have a new data, we identify new geological structures, identify new earthquake sources. So it is quite a dynamic situation, and every time we update the situation, that means that we have to make our standard higher. That means higher cost. So we have slope stability problems in many hilly and mountain areas. And we have some problematic soils, soft soils, spit soils, expansive soils. Also, we have very unique clay shell in many places. And also, we need to consider earthquake-resistant design. I think this one you already learn a lot. Basically, about 90% of our region is hilly and mountainous areas, where the landslide, soil stability problems happen. In the old days, people tend to stay in the lowland areas, but with the increase in the population, many critical area in terms of the landslide also occupied by the people, and it creates problems. People approaching hazard areas, not the other way around. So in the planning stage, we need to have a kind of vulnerability map on many type of hazards. Landslides, we are talking about tsunami, earthquake, also flood. And the purpose of this map is that to how we strategically approach in building or maintaining our infrastructure stocks. Yeah. For example, in the hilly areas, mountainous areas, of course, we have to prepare a higher budget for construction. It can be 1.5, even 2 times than in the flat areas. And also how we anticipate if disaster occur. How we put our what we call disaster relief unit, equipment, etc., and power. Because we have a standard, for example, in the road infrastructure, then when landslide happens in the national road, in terms of 6 hours, equipment should be already mobilized. So this is, I think, also we have this is the problem with the infrastructure. The more we need infrastructure, the more disturbance we make to our earth, and it creates some kind of potential hazard. So this is the problem we have. Yeah, we have soft soils, we have peat soils, we have expansive soil, we have other problems related to the residual soils, clay cells, colluvial, etc. And our problems with the soft soils and peat soil, because our main economic region lie on the soft soil and peat soils. Our economic center, ground center, is in the north coastline of Java, which is soft soil deposit. Eastern coastal of Sumatra, which is also soft soil, and southern part of Kalimantan, and all the coastal area in the Papua and Sulawesi. Also, we have on the inner land the problematic clay cells. Yeah, we have problem with the extreme mountainous areas. So the area of the soft soil and peat may be only 10% of our land area in Indonesia, but that is the place where our economic ground center lies. Okay, so how we define soft soil? These technical issues here. Some say that unconfined shear strength below 25 kPa, others say about 40 kPa. But that is not the real issue. The real issue is that the failure of our engineer to identify the magnitude of the problem create a lot of problems in the construction stage. And it still occurs in Indonesia because people tend to save in every business process, tend to save in every steps of engineering process, even in the design process. tend to pass down. Yeah. But I think our experience says, and many says, that we need to spend more to save later. Yeah. So cost of run in Indonesia is still high. Yeah. In some areas, for example, yeah, in the extreme side, when we build now, we are still in the construction of the toll road in the section of the Serang to Panimbang. Yeah. The cost of run is about more than 2 times than what we calculate in the beginning. Why this happened? Because the poor data of site investigation. Because of the saving people made on developing data of the site. And the second issue is on the quality of data. I think this is one of the main issues related to the subsurface investigation. So also we have in Kalimantan, for example, in the central Kalimantan, in some part of the East Kalimantan, we have also pit. And our pit is a bit different in the pit we have in the, for example, European countries, for example, in the Netherlands. They said that pit is organic content more than 40%. In Central Kalimantan, when we build road infrastructure ITC, the pit content is more than 75%. So basically it is water. So the approach should be different. Yeah, the approach should be different. Many of our pit is relatively young, even 4,000 years old. In Europe, maybe this much older. And also on the expansive soils, we have a great deal of problem with the expansive soil. We have that one in the exploration site in the Bojonegoro area. You see how the road is still deteriorating in there, and also in the toll road of Cipali, and we have also Bubonaro Clay in the Timor Island. And this one, the cost, study in America said that the cost of due to the expansive is more than any cost due to natural hazard. So the cost of due to the expansive is quite big actually. And our understanding on how to deal with this problem also, we need to improve in our challenge. Subsoils, I think we have problem already. I already told you before. Common problem, the failure of the road department, and many cracks in our roads due to differential settlement. And clay shell, I think we are talking about the for example, Pulara, Toro, Cisumdawu, Toro, many areas. Maybe we are going to construct road from the Bandung to Cilacap, and our assessment maybe also we have this kind of soil, and it costs us a lot because the characteristic of the soil is quite unique. Yeah, because it is easily crumbled, and shocking in the world. This is the example of the problem with the clay shell and the Cisomang Bridge, because it was a national issue later in that time, because we are nearly crossed this bridge, and this is the main trunk road connecting Bandung and Jakarta. And also the many landslide in Cipularang. If you are old enough to remember that we have problem when we opened the Cipularang Toll in those days. Okay, the small problems, yeah, we have a lot. And now the main theme or the main message I want to convey to you is that where is the role of the engineering geology and civil engineering? Because engineering geology and civil engineering should be in hand together to make the better solution. So we are talking about pre-feasibility study, conceptual stage, initial assessment, and then detailed engineering design. In the first phase, in the beginning, the role of engineering geologists is quite important because it contributes, because it delivers inputs to the modeling of the civil engineering analysis. The wrong modeling create wrong analysis, create wrong design, and create failure during construction. And when the detailed design, the civil engineer, the geotechnical engineers will the role much more dominant. But then on the construction, geotechnical engineers, engineering geologists should hand in hand together again, because we anticipate the uncertainty of the modeling we develop in the design stage. So I think the feedback or the inputs, the advice from the geologists, the engineering geologists is quite important. We have experienced so many, our model is not valid enough when we step into the construction stage. And it creates many problems related to the budget allocation, related to the unanticipated failures. And it costs a lot of fortune. So I think this is the main message we'd like to deliver to all of you. Yeah. The good identification of the subsurface condition, very important how we save the cost on the construction stage. Yeah, wrong assessment create the wrong design, and then the failure is very costly because infrastructure is one way around. It's not a cyclic process. Yeah, once you construct it, and then you have failure, and it's a nightmare. Here is some example of the engineering solution of the subsoil problems related to road construction. But the important thing is that there is no solution for all problems. Each site has its own characteristics. Yeah, so that's why innovation is very important in dealing with this kind of the geotechnical problems in road constructions. So the conclusion is that geology is very important on providing valid inputs into the engineers for planning and for detailed design and for mitigation during construction. And we understand that with the complexity of our geological condition in Indonesia, we have a tropical climate, which is significantly different in some aspect compared to the temperate soils. Also challenge us to better our understanding on the behavior, the characteristics of our soil and rocks in Indonesia. And also we have problem with the earthquake, which we still learning and we still updating. Yeah, how we adapt to this earthquake hazard for mitigation of our infrastructure resistance. And that's all I think what I want to present to you, and I'm very happy to question and answer. Thank you, moderator.
Okay, thank you very much, Dr. Hedi. Please give applause to Dr. Hedi. And Dr. Hedi, could you stay and stand by in your Zoom? And next will be the next panelist, Dr. Johan Arif will give a talk. And the question and answer session will be after the presentation of Mr. Johan Arif. So, Mr. Johan Arif, are you ready for the next presentation? Okay, you can use in the stage or, yeah, depend on you. Please.
Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, salam sejahtera buat kita semua. Terima kasih Pak. Tadi Dr. Hedi sudah menyampaikan hal-hal yang sangat penting tentang infrastruktur. Sorry, I talk in bahasa. And now I'm going to move the subject into one of the hot commodity, gold. Anyone have seen what is the gold price lately? Anyone knows what is the gold price? It's keeping the record to 2,500 at the moment. It's one of the highest gold price. And any student taking gold topic research or exploration? No one? Oh, very good. God bless you, Pak. Because the gold price is so good. And secondly, UGM has, I think, historically has one of very good department in gold exploration. You have Pak Lukas, you have Pak Arifuddin, so you are in a good hand. So that's why I would like to talk about our experience. And I'm very grateful to be invited to this session because I think this is a good opportunity for me to share what the industry has been doing lately, sharing you some information so you get some idea that's probably not covered in your ordinary lectures and things like that. So at least you got some idea, oh, the industry has been doing this. So this is very good opportunity, and I think we need to strengthen more between the industry and the academic because that's the way we actually can excel the benefits, knowledge for our goodness of this country. Because Indonesia, as Pak Prabowo said, every mountain has gold. So we need to, what you call it, we need to prove that. So Pak Lukas have a very heavy burden to prove that. Anyway, my topic is on geometallurgy and the lesson learned on refractory ore. Why refractory ore? Because, next slide please. Okay, let me talk about geometallurgy first. This is probably just a very common term. Geometallurgy, it's a discipline approach combining geology and metallurgy and planning for fundamental understanding of economics. That's from Dunham, yeah, from QG. And you can also read the second paragraph, basically to combining the discipline between geology, mining, and processing. But for me, as industrial, what you call it, pelaku industri, yeah, to me it's maximizing the value of mining operation. I will show you the next slide. Next, Pak. So, where are the, this is from, what his name is, Chow, 2020. I got from one of his slides. It's not one of the best slides, but at least to show you, this is the mining cycles, and you have that steps of exploration, conceptual study, geomet there, and there will be like FS level, process design. This is a kind of ordinary steps when you do the exploration, in gold exploration. When you work into the company, especially for the geologists, usually he will be in the early phase of exploration when the deposit was fine. And from there, the geologist will define the model and how big is the deposit, and he will make the FS to make sure if this is economic or not. And that's where the geometallurgy comes in. Basically, it will give you some information. What will be the best process path for this deposit? Is it going to be gravity CIL, or is it going to be POX, refractory, and things like that? So that is where the the interaction between geology and other department. That's probably the first event when you have to face with metallurgists. Metallurgists is different kind of person. They are a bit difficult to talk, so you need to understand them very well to be able to have a good communication. Yeah. They will not talk about spatially, they will talk about only numbers. That's why we are very different. And that's perhaps creating difficulties in this study. But I have some little bit of experience. Basically, you can do geometallurgy, start from the beginning of exploration. If you know what to do. You don't need to wait until it's being drilled by like 100,000 meters and things like that, and then you do the geometallurgy. What happened? Because when you do that, you need more samples. Sample packs that have already been drilled 5 years ago, 10 years ago, it will change the characteristic. So it will best if you start from the explorations, you just take some samples and things like that to do the geometallurgical analytic. How to do that? You need to talk to metallurgists. If there is some metallurgists in the company, talk to them. What kind of tests, what kind of information that needs from you. That's very critical. I've been like 25 years in this industry. I just learned this for probably like 5 years ago or 10 years ago. So you do not have to make that mistake again. So when you do becoming geologist in exploration, start from beginning. At least you are aware that we need to do some geomet in the earlier phase. Next part. So this is the challenge of geometallurgy. On the left side is us, geologists. We are on rock focus, in ground. What you mean, like you look at, oh, the rock is hard, the rock is nice, beautiful, texture, good, mineralogical, disseminated, things like that. But that word doesn't mean anything to the right side, which is the metallurgist. They only need, is it going to be numbers like this, and what will be the, response? And is that can be like systematically delivered and things like that. These crossing disciplines sometimes doesn't work well because the language is different. See, I think this picture is showing you the very typical problem when you talk to metallurgists. We talk about colors, while here talking about the engineering or machines. So I guess what I'm trying to say here or to share, we need to be proactive to metallurgists. Hey guys, what do you need? So when we try to translate our language into their language, don't force your language to them, otherwise they will not understand. So for instance, like clay. Oh, we have a lot of clay. What is clay for metallurgists? They only knew that this is soft or this is hard. Oh, meaning, oh, this is a lot of, impurities or something like that. So those things need to be bridged or translated into their language. Next, Pak. So these are the three things that I think from my own experience, for having a good metallurgical or geomet study, the first thing is you have to know your ore body. I mean, you have to be a good geologist, of course. First, you have to be really, really good economic geologist. You know well the deposit, you know well the distribution, variability, you can make the 3D models, and you can get the information on ore, where they are, what are they with, and also some variable metallurgical response, for instance, the hardness, the clay, or other things. That's the first, what you call it, the first thing that you have to have. Second, based on my experience, maybe you are really good on geology and you know well, but if you do not have communication skills, yeah, it won't work. So that's the thing. This is very important. You need to spend more time. If needed, get a metallurgical friend, so you can talk intensively. Yeah, except some of my friends do that. And then third, understanding our customer expectation. This is also trying to basically, what you call it, translating. You know in advance, oh, they will need this, they will need this. So you're not on your silo. I will show you some of the case that I've been working. For instance, exploration geologists, we only focus on gold, for instance, gold or copper, yeah? Because this is porphyry copper or this is high sulfur. But at the end, when it goes into production, the most important thing that needed by metallurgists or the processing guy is not gold, it's sulfur content. Why? Because it will optimize the size of plant. Gold will come later. So when you know the size of sulfur consistently, that's the most important information that they need, because it will optimize the economic of the, what you call it, the operation of that plant. So those are the things that you need to know in advance when you work with your deposit. Next. This is I take from Burido, which is my friend. She is the metallurgist. These are the example of deliverable in metallurgists. What they want, they actually want single most suitable processing route. They always want, you know, very simple. But we have to work hard to make sure this happen. And single recovery value, because if you have one single recovery value for the whole deposit, which is impossible, it will be best thing for them to plan, to make sure the production achieve what they want. And third, it's like identifiable critical association of production and things like that, which is this is variability. And also they need to do go or no go for the project. So you need to translate that into our expertise, geology. So to have this thing, what do we need? First, for instance, we need to understand the deposit well by creating a very accurate 3D models in gold content, copper content, base metal, sulfur content, and other things. And third or two, is there any way to engineer this? For instance, because of the recovery in top is high, below is low, you need to blend or something like that. So you have to give some input on this. And why? Why is up is high, bottom is low in terms of recovery? You need to answer that in terms of geological responses. It's because of the oxide or because of the gold sulfide content and things like that. Next one. So this is the common geometallurgical stage. Usually, the blue one is geological part, yeah. So our exploration geos or geology need to prepare usually domaining. So when you have the deposit is been found, you have to make a domain. Domain is a small cluster of the big deposit, either gold grade, or copper grade, or lithology, alteration, whatever that geology can define detailedly. You need that kind of thing, because that will help someday to answer the questions, why there are some variabilities. Basically mapping the variabilities in terms of geological domain. And then you have that representative sampling, collecting, that I can talk that days, but we skip that. And then the metallurgist will take part of this, or characterization, valuable extraction, variability. But this is like one cent pack, yeah, front and back. So you can go actually from there, and then our characterization, you find our characterization is different, you're coming back to domain. You will revise the domain again. So this is where the works like need intense communication. It's not like one way, it's both ways. So every domain will impact our characterization will impact back the domain and things like that. And then at the end, you will agree with metallurgists, this is the best to process this thing, something like that at the end of the day. Next. So this is just examples that I've been working. When we do the domaining that I tell you earlier, usually we try to create the general model, yeah, and domaining, which is first is based on qualitative section. You do observation, mapping, host, and then you do the sections. These are the sections that you usually have: host rock, alteration, mineralogy, mineral system form, clay, whatever. But as a hint, yeah, because the deposit is big, usually my personal experience, take the best section or the most representative section, do the whole domaining from that. Try to make detail one first, and from that you will step out for the whole deposit. It will help you to work this fast, rather than you just do the whole things in one by one geology, but make a one single deposit model. Once you have that, it will be much easier to do that. Next. This is the example of how we do these things. So this is more interesting for geology. We have alteration, we have mineralization, sulfide, Pukubomo, crude cell. Why we have sulfide? Because some of this deposit has oxide ore, sulfide ore. We have some oxide on the top, Pukubomo. Puku is piece of completely oxidized, and that means that on that red color is basically oxidized, but below it's still on the sulfide, stage. So this is actually done by our geologists on site. This takes months, hundreds of drill core. If you see this, a lot of based on the drill core and things like that. And we actually combine with the metallurgical test to make sure that our geology talks directly with the numbers. So for instance, this is oxidation, yeah. If you say Poko, which is oxidized, it has to be from metallurgical perspective. It will give you good numbers when you do the quick lead test. Why? Because quick lead test is good for oxidation. So we have to make sure that numbers correlate. For instance, that in the center, quick lead test is above 70 or 79%, which is, it's confirmed. Our visual observation is confirmed by metallurgical numbers, something like that. So this is back and forth, because you have this data, you have to make sure that's actually, confirmed. Next. And then we also have to do domaining and subdomaining from quantitative, which is usually we get these numbers from ACEs, yeah, from drill core. So you do that as well. You have this head grade, base metal grade, quickly test, and usually the very important but not done by a lot of company is the deportment study, because this is need a lot of effort. And also for the last part, which is very, applicable for sulfide ore, is the sulfur content, as I mentioned to you. I will tell you later on this next slides. Next. So this is the example of when we already done the domaining model, which is a 3D. You see on the left is the main geology model. We have like A to F domaining, which is geologically distinct or different, but also have a response in metallurgical also different. So we can classify that. But on top of that, we can do the subdomaining based on specific metallurgical response. For instance, this is non-refractory, or this is semi-refractory, this is refractory. You can do a lot of this subdomaining in 3D based on the information that you have. Basically, these are the most, product that need to be delivered to metallurgists and mine engineers to work on mine planning and also economic of the deposit. Next. This is the example of gold deportment. This is basically from the oxide ore. What you need, basically you need to know where is the gold is. Is it free gold? If is it free gold, how big they are? How do you know how big they are? You need to do a lot of thin section in microscopic. You have to measure that. Why? Because it has, later metallurgists will ask you if there is some metallurgical response and test have a different things. This number will help them to understand, oh, why the quickly test is low, even though it's oxide. It's because the gold is big. They do not have time to dilute the gold. Quick leach test meaning a quick leach, which is like test 1 hour, 2 hours. If the gold is big, they will not have time to leach. And if the gold within the sulfide, like pyrite, arsenopyrite, how they are actually occurs, you need to do laser ablation ICPMS. This is the one thing that I've been complaining a lot to Pak Lukas as well. We are, as university in Indonesia, I never have able to do this laser ablation ICPMS. This is the key to understanding our department, and none available in Indonesia. My master's I did in 2002, I did in Australia, very easy. I can go to Macquarie University, ask for 3 hours. Can I do this laser ablation? Yes, you can, just pay. Now, 20 years later, none. So I have to go to New Zealand, I have to go to Australia to do this. So I don't know why. So this is a kind of linkage with industry. This is, I know it's expensive, but industry willing to pay if there is here. So these things is a very critical. I'm not sure in the other department, yeah, metallurgists, or in the material faculties and things like that. But if there is, I will do this here. Next part. So why sulfide ore? I've been working with this sulfide ore for the last year or so. We encountered that at the moment, the discovery of new deposit is very difficult, especially the surface deposit, yeah, which is oxide commonly. And now, most of the ore that has been mined is deeper and it's depleted. What we left is the sulfide ore. Sulfide ore is expensive and difficult to process. I will explain it later why. And increasing metallurgical property. But, yeah, if the geologist knows the detail of where they sit in sulfides and understand where they are spatially, it will help the metallurgist, or even perhaps change the economic of this deposit. We thought that, this is not possible. But when you know that, the detail like departments and that it may improve the economy because we know where they are. Perhaps when we say the oxide, it's not really oxide, perhaps like 50% of oxide, based on our geological information and study. This is the real case, and we did in our company to do that. Next part. I'll talk about, okay. So what is the, for you, student who's not really, what you call it, not really exposed to this kind of things, just easy. When you see this section here, this is actually martabe. The top red is oxide. Its recovery is very good with CIL. Yeah. Below is actually the same deposit, but it's not oxide because the oxidation is still deep. On the up. So that's where the gold is sit within sulfide. That's why the recovery is low. When the recovery is low, the economic is low. So you cannot mind that. You see the black line is the pit limit. But if you can process those, you will actually get this gold, or what you call it, or conservation, yeah. So this is also for benefit of the country. When you do mining all of the resource, it's actually coming back to our country, coming back, we pay tax, coming back to our government. That's actually also supported and enhanced by mine energy departments. So if you can do and mine the existing resource with the blue, which is still down below, that will be a very good for the country. So basically, when the you can read here, free milling is easy, refractory is hard. Why is hard? Because it needs more process, oxidation pre-treatment, or perhaps also ultrafine grinding. But this is the most important. You need to oxidize the sulfide to be able the cyanide leach the gold. That's basically the idea. And that's the common route, free milling, if you have the recovery above 95%, refractory, and highly refractory when you have less than 50%. Next. This is just to show you that from free milling to refractory, basically it's high capex. Why capex? Because capital, you need to put more, you have to put more processing equipment, like POX, what you call it, roasting or other things, I will tell you later. And also the high OPEX, operating cost is high. That's why the cutoff grade for sulfide usually much higher than the oxide because of this processing cost. Next. Okay, this is the refractory or process option that I know. Perhaps Papa or Ibu dosen maybe know better than me, more than that, but this is what I know. Roasting is basically thermal process with a high temperature, 600 to 700, basically to transform the metal into oxide, because this is sulfide, and then because it's been burned, it's jadi berkarat ya. Jadi kalau besi dipanasin karena ada oksidasi, itu pasti berkarat. Intinya cuma itu aja. It's high cost because a lot of power and energy. Biox, this is a very quite recent development. This is green what you call it, green initiative, because we're using bacteria. We're using bacteria to consume the sulfide. So I went to one of these plant in Philippines a few months ago. Basically what happened, they have a bacteria, which is a bacteria in the garbage. Yeah? The bacteria will produce, what you call it, HS or something like that, sulfur acid. The acid will actually oxidize the sulfide. So it's not that bacteria eating sulfide, it's not. Bacteria will produce the sulfuric acid, and that sulfuric acid will consume sulfide. When the sulfuric acid consumes sulfide, it will becoming oxide. The third one is POX, pressure oxidation, is basically using autoclave. I checked one of this in China last week, basically in last Tuesday, and China has a, what you call it, amazing technological advantage. So if you have opportunity to visit or to work with them, go. They have a lot of technology which is far advanced than the Western country. Sorry to say, yeah. And the third one, the fourth one is atmospheric. It's basically ultra fine grain, and the oxidation without pressure and heating. This is the place that I never visit because it's like IP, yeah, intellectual property. They call it AUN. It's not many companies use this because this is owned by one of the company, the intellectual property. Next one. So to give you some view why on how the gold process. If you look at this on the left, on the middle, you see the yellow is gold. It's easy because gold can be liberated, big grain, and also on the right, it's okay. So you don't need to be oxidized to get the gold. But when the gold like this, in the center of the sulfides, or even in solid solution within the other metals, that's where you need to break the bond with the sulfide and oxidize one of it to be able cyanide to leach this gold. But for the top, this is oxide or what we call easy. So to be able to know this, you have to do a lot of petrographic. So if you're interested at gold exploration, take petrographic major, yeah? This is one of the key to understand how you do the process thing. Next. This is case study that what we did in our company. We did a lot of thin section, and some of them actually I did myself. We do the polyethylene section, and this is the laser ablation. You see, that point there is where we ablate this sulfides or pyrite, and the red color is the gold content in the pyrite. So even you cannot see the gold, but the gold is actually there. So this is why this is part of the sulfide part ore deposit. So we'll do this in detail, paragenetic. Where are the gold? Free gold, gold in pyrite, gold in arsenate pyrite. We see the grain size, and then we have the laser ablation result study, including the other base metal, because when you do the laser ablation, basically the ICP will read everything from gold, base metal, and things like that. It's the same ICP stuff. And then also the occurrence. This table is one of the key to answer metallurgical question in geomet study. So once you have these things, it's almost there. The next one is to make sure you know spatially where they are. Where are the gold that most of them are free? In which part? Where are the gold which on solid solution? Which part? Something like that. They need to know this because they will plan accordingly. The mine plan, how big the plan is, how big the pabrik untuk mengakomodasi ini. Next. So, these are some of the critical information when you have this kind of processing route, roasting, biox, or whatever. The black part, it's quite common. Either in you other deposit oxide, you will need that anyway. But the red part is very, very critical if your ore is in sulfide or refractory. This is what I learned actually, hard way, because we have the deposit and we have been drilling since 30 years ago and things like that. we do not have this sulfide content information because we think that we only need gold, copper, and things like that. So what happened? We have to coming back to get old drill core samples and things like that, re-assay. If you do that early phase, you might save time and money. And the problem, another problem when you need to re-assay the old samples in the core set, it's actually oxidized. So it will give the different, response. So those are the hard learn that we learn, the experience that we learn. And also, when you do that, do as well the penalty elements and deleterious elements, because the metallurgist will ask you this. Rather than you coming back again, you will prepare with already some answers for them. Next. So this is the example on spatial. Yeah? So the thing is that year 1, 2, 3, 4 is the mine plan based on the mine plan. They do the, because it's open pit, so they do the planning, phasing, and they will have the ton information. Geology part, it's from gold to the right. You need to give the gold content, sulfur content, clay, and things like that. So what happened when we see this graph? It's a bit shocking to the metallurgist and mine engineer. Why? Because if you see, like, for instance, for sulfur content, we say that the average is 3. But there are some years that you have 5%. This is not acceptable for metallurgists. They cannot, accept this kind of double, because that will be bottlenecking in the processes. So what happened when you do this information? You need to redo the mine planning, the fish. Or you have to mine there first, you mine there here. So who lead that information? It's geologists, because geologists have the 3D models. So you have to give them the 3D models and, okay, do like that first, and then plan with this, plan this, plan with that. So this is becoming very interesting. So to be honest, when you become geologist, you will feel proud, oh, my work has been useful for this company. So because you can translate your information, your knowledge to other people. So because this will ultimately define this financial return. At the end of the day, we work for the finance, yeah? If you work in the private company, they will ask you, hey, how much money and what is the return? At the end of the day, is that. But before that, you need to make sure all the data, all geological information works the best way. Also like clays or other things like arsenic, for instance. Arsenic can be very dangerous. They will not accept, oh, the first years is okay, but in the 6 years it's very high. We need to adjust that in the same level or something like that. Next.
5 minutes, Pak John.
Okay, this is my last slide. So, in summary, this is the thing that I would like to share to you. First, understand your deposit well, meaning you have to have a good geology. How to become a good geology? Mapping, more look at the rock, yeah? Spend time at the rock, talk to the rock. Because that's the more important thing, yeah? Not only looking at the computer. I know most of us now bombarded by the software and things like that, 3D scaling, yeah, that's good. But the most important thing is the philosophy behind that, yeah? The geological model, your information on the lithology, alteration, and things like that. Once you get this well, you can go to the next step, which is modeling, 3D, software, whatever. But that's number 1. Number 2, department study. This is the things that I saw in my back days in university. We not really focus on to look for. What to look for? Oh yeah, just lithology, this is granite, or this is diorite. Yeah, that's good. But more importantly, we look for where they sit, where is gold, where is copper, how they actually interact with these guys. This is going to be the answer for the maths, because when the maths asking why this is reflecting different response to metallurgical test, that's the answer. And the last one, this is also that I encourage you, learn more on the downstream process. If you know that you're going to do in the mine geology, you have to know what will be this going to be processed, because that will guide you to focus what information needed by them. Not because of, oh, I'm proud of geology, I just need this geology, gold, or porphyry and things like that. That doesn't mean anything for them. So, for instance, like sulfur, where there are sulfur contents, or arsenic, and things like that. How to do that? Be proactive, yeah? Learn or talk to the metallurgists or take one of the elective in metallurgy or something like that. If you know what to do or if you want to go in the gold business. Thank you very much. I hope it will be benefit for you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Pak Johan. And yeah, very interesting talk for both of presenter, Dr. Hedi and Pak Johan. And both of them also talk about the same or similar topics, the applied geology. So Dr. Hedi talk about the applied geology for the engineering construction, and Pak Johan talk about geology in the mining sector or the geometallurgy. So now we move to the session of question and answer. So I give opportunity for the audience to give questions for the presenter. So any students or the audience have a questions for the presenters, maybe? So not yet, maybe I have some questions. First for Pak Hedi, yeah. So based on your experience, Pak Hedi, what is the most geological factor challenging for road constructions in Indonesia? So in which location that that geological factor is affecting much in the road constructions? I think that's my first question. And the second question is about the target of the travel time in Indonesia. Do our government have a target of the travel time in Indonesia? I think that's for Pak Hedi, and for Pak Johan Arif, maybe after Pak Hedi. Also based on your experience in the gold mining, is there any experience that the metallurgical test result is completely different with the geological model, and how to solve that situation? That's for Pak Johan. And maybe Pak Hedi first, if you have an answer for that. Thank you.
Thank you, Pak Nugroho. Interesting question. The problem with our infrastructures, and actually our center of population, is they live in the problematic areas geologically. And we have many problems in the soft soil, particularly, and then related to in the mountain areas, in problematic soils, particularly clay soils. I think this is the most challenging, and it makes a very high construction for our infrastructures. Yeah. And then on the travel time, I think the main goal of why we have to reduce our travel time, because we are naturally in the competitive environment economically. So when we are asking what is the target for travel time, and then we have to be competitive enough with our competitors, our peer groups. For example, Malaysia is in the order of around 1.1 hours per 100 kilometers, and we are still way higher than that. Of course, it is quite challenging, and it need a lot of financing. But our logistical cost juga also not so competitive overall. Yeah. So the travel time ideally is we are in par with our competitors, which is in the order of 1.1 hours per 100 kilometers. Thank you, Pak.
Okay, thank you very much, Pak Edi. And maybe Pak Johan.
Okay, thank you, Pak. The question, I guess, on can we prove that perhaps the metallurgical response is wrong? Yes, we have one experience, one of the deposits. Originally, it was regarded by metallurgists that the deposit is mostly sulfide. Why? Because they use the analytical tool that called KLT. KLT is quick leach test. What happened is they're trying to leach the gold within 1 hour, and if the result is like 75% more of the gold being leached, that's oxide. But if less, that can be refractory or semi-refractory. When we come back to this deposit, we knew that the oxidation level was actually deep, but the recovery or geological metallurgical model shows that on the top it's refractory because of the KLT. So we did the geomet study, we did the thin section, we knew that the gold is actually coarse gold. And that's why we proposed to metallurgists that everything above the oxidation line, it's actually oxide. But they're insisting, no, based off the KLT, it's transition or refractory. And we then ask for the metallurgist. So if we have a different, call, or if a different idea, what is the best way to judge this? And we propose that, okay, instead of we leach 1 or 2 hours, we're trying to leaching in the lab for like 24 hours to make sure that if there is still gold, it will be leached out because of time. And alhamdulillah, it was proof that it was actually leached out more than 80%. So it's actually opening my mind as well that, wow, this gold department is very critical because some metallurgical, criteria or tests that they have, they never consider the real gold department in the deposit. They just look at the numbers or something like that. So yes, Pak, we can actually prove them based on our geological information. If no one actually goes that far, geologists, we will just accept the metallurgical model. It says, okay, what happened? The mine will becoming very expensive and not economical because of that part of the surface deposit. It's sulfide. You need more capex, you need more opex. But since we proved them that this is oxide, they think no, oh yeah, it can be more economical because it's more cheaper to process this thing. So that's where the geology information and also geomet coming in, Pak. That's the real world situation, what happened. Thank you.
Okay, thank you very much, Pak Edi and Pak Johan. Okay, I give opportunity again to the audience. We will have already one questions. Any other? Maybe? Yeah. I open for 3 first. Yeah. Okay, second Pak Lucas. Yeah, first.
Yeah.
Please introduce first. Yeah.
Thank you very much, moderator. My name is Santosa. Actually, I'm a civil engineer from the next door to geological faculty, but I'm eager to learn about geology. So please bear on me if my question is not so proper for geologists, but at least I have a question for Mr. Hedi. In road development in Indonesia, how far is we also consider about the not only geological state, because geological state probably almost not so much changing in for human time scale, for example, 500 years to 1,000 years, but I'm talking about geomorphological change like river meandering, natural subsidence, or natural land movement and everything. How far we also consider it in road planning and road construction in Indonesia. Second question is for Mr. Johan. So in your presentation, you provide an example on the mining plan in 10 years like that. For example, in the first year, you will get to the investor, you say that you will get a megaton of gold in the second years and everything. And do you also provide uncertainty range on that prediction like that? So probably there are some process that we don't understand it quite well, or the application is not as what we expected. It might change the predicted outcome of the mining. So do you also considering uncertainty and provide it those data to the investors like that? Thank you very much.
Okay, thank you. Please hold to answer, Pak Hedi and Pak Johan. Maybe second question first. Pak Lucas.
Thank you, Lucas Duni from Geological Engineering. But even I'm geologist, I'm not mastering the geotechnique, yeah. And my first question to Dr. Hedi is, as non-specialist in geotechnique, I would like to get some idea related with geological aspect that you mentioned always important. But it seems there is always geotechnical solution for any geological formation, lithology, etc. And as non-specialist, I consider that it seems that civil engineering or geotechnical engineering consider that any different geological condition can be overcome by engineering or rekayasa, and then at any cost, yeah. So then I observe, for example, again as non-specialist, then there are many projects that becoming more excessive in the cost. For example, rapid train from Jakarta to Bandung, that the cost is becoming increasing. And very sorry to say, for example, our new capital, why the area is selected to be built on the siltstone. Also, there are many probably better geological conditions. So I like to know, in terms of geological factor, is there any selection criteria, not only to overcome the geological problem, but also to select the best site for infrastructure? Thank you. And then for Pak Johan Arif, I'm wondering that you mentioned also you have more than 25 years of experience. You mentioned that you just realized the problem with geometallurgy in the last 5 years. So what drives the current situation that geometallurgy today is more important? Is it because the government restrict the exploration in new area, that every holder of mining concession must optimize all the opportunity? So because it is not possible to work in new green exploration area, then all the mining concession operators must focus in optimizing the resources. And then secondly, what is the current solution when the ore body transfer from oxide zone into refractory ore? What is now the best solution? Have you found the best solution today, or it is still in the a process of looking for the best technology? As well as beyond your project, is it a common feature in many different gold projects in Indonesia, in which then if you already have solution in your project, we can look for other opportunities in similar situation in other Indonesian projects, learning from the success story from your project? Thank you.
Okay, thank you very much for the audience. And I give opportunity first for Pak Hedi. Maybe you can answer 2 questions from the audience.
Okay, thank you. Both for Pak Santosa and Pak Lukas, actually there is a standard procedures in the infrastructure development, what we call terrain evaluation. So this one pure, mostly geological people should do it. Yeah. But to be honest, this is not common practice yet in Indonesia. We have still had to promote the use of the terrain evaluation assessment, particularly in the beginning of the projects. So the terrain evaluation is to identify of the morphology and geological features of the area where we want to build infrastructures, and then by that, then we choose which road alignment, for example, road corridor better build to minimize the cost. Do we consider I would say climate change, something like change of mandering? Yes, but the problem is that we can do everything, but it needs money. Yeah. For example, now we have experienced so many bridge abutment fails without the structural failure of the bridge. This is why, because the flood, the position of the abutment of the bridge is not long enough anymore, because the depth of the river flow is much higher because of the some of the change of climate issues here. And also we observe that the return period of flood, for example, is no longer valid now. Yeah. So when we calculate the debit, for example, for 50 years return period by current standard, actually it happened maybe 40 years or 30 years. So then we should approach this problem by adapt to the situation. Of course, we have to, but again, it depends on the budget constraint. Yeah. For example, we make the bridge longer, it means cost increase significantly. And then on rapid line, yeah. So the issue is that not why we choose certain location which is problematic, but sometimes people want to do in that problematic areas. Because problematic areas, as I said before, mostly is the center of the economic activity. Northern coast of Java is where the big ports operate over there. Yeah, and big cities in Java, mostly on the northern coast of Java. And then people, oil, gas, so they have found the oil in the eastern coastal areas of Sumatra, which is pit and subsoil deposits area. And by then they develop a kind of communities, housing, and then city. And that's the problem, that we have to go to there, not because we choose to go there, but we have to go there because there is need. Yeah. For example, the rapid train Jakarta-Bandung. It is because we need to connect Jakarta-Bandung. The problem with, I think we have a big problem over there. Yeah. when I think the Chinese contractor company construct the tunnel, and they never experienced before how to handle with the clay shell. Yeah. Because they don't want to involve our local engineers. And by then, they face serious problems on tunnel construction because a lot of failures on the lining areas. So I think local engineers, in terms of clay shell, for example, in Japan, is they understand better the characteristic of the clay shell. Nusantara Capital City, I think study by Bappenas, also by Minister of Public Works, I think already long time ago, and we have some options for the location actually in the Central Kalimantan, in the East Kalimantan as we have now, and many factors, not only geological factors, and actually geological factor is not so dominant over there. Of course, we have young fall over there, we have siltstone, but the problems relatively mild in terms of geological condition. I think other factors why we choose capital city over there, because in the East Kalimantan, in the Balikpapan area, so many infrastructures are already there. We have two big airport, Samarinda and Balikpapan. We also already Balikpapan, Samarinda, toll road. Yeah, the problem is that the area is hilly, so that's the problem. But in terms of engineering related to geological conditions, I would say it is mild. And another problem is water, because there is no big river. Yeah, we understand that our ancestors developed city, town, usually close to the big river. But in the Balikpapan, the river is not so big. So I think in the future, we have to take water from the Mahakam River in the upstream area. That's my response. Thank you for the question.
Okay, thank you very much, Pak Hedi. And I hope it answers all of the questions. And Pak Johan, maybe your turn, but a little bit short.
Thank you, Pak. Sorry, can you repeat again the question, Pak Santoso? Uncertainty. Yes, Pak. It depends on the states of explorations. Usually, even pre-FS can be like 30% to 25%, and also depends on the time scale. If we're talking about, let's say, weekly production compared to annual production, the accuracy will be different. Annual usually be less than 10% or 5% can be, but weekly can be very high. So that's come back with the accuracy of the data. Thank you. And I hope that answers your question, Pak. And the second one from Pak Lucas. We did this because of, not that we are very smart, it's actually because of necessity. It's because of internally necessity, because there is no other mine that we can process, and other factor like Pak Lucas said, correct, because of the regulation and things like that. So the power of kepepet itu, it makes you smarter. So I guess my, my suggestion to you when you apply the company, try to find the company which is struggle. The deposit is very difficult. There you will learn a lot of things. Thank you very much.
Okay, thank you very much for all of the two of the presenters. And yeah, I think all of you maybe still have a lot of questions want to give to the presenter, but time is not enough, and we have to move to the other place for the other presenter. And let me conclude this panel discussion that strengthening the industry and academia, which is our topic today is very important to give us solutions and to solve the problems in every geological environment, not only in the mining sector, but also in the construction, especially in the engineering geology. So that's the point, and I hope the students will get it and to make your target after you finish your study in geological engineering UGM. Okay, finally, please give big applause to our presenter. Thank you very much to join with us, and thank you very much for the audience for the collaboration and cooperation. I give back to Mbak Ica.
Thank you so much, Dr. Nugroho and Dr. Hedi and also Mr. Johan Arif. Thank you to all keynote speakers who joined us yesterday, and one big round of applause, please. Thank you so much. And another day, another cup of coffee, rice and green, it's coffee time. Hence, we proceed to the parallel session. But before that, please enjoy the refreshment, coffee and tea at the hall of this auditorium. And we shall resume around 10:15 for parallel session in meeting room 1 and meeting room 2. Thank you very much. See you soon.
Hello there, we are Adi. And we are more than a construction company. We are beyond.
Beyond what, you ask? For us, green is more than just the color and the movement. It's beyond. It's a commitment to further invest in ESG and surely to reduce carbon emissions from our breakthrough.
It's planting not just that small tree. The 1,000 actions of green in different locations.
Amazing, right? Yes, we are Adi and we are beyond.
Setiap gerak kami adalah fondasi untuk menjadi perusahaan energi kelas dunia yang peduli lingkungan. Kami memasuki era digitalisasi dan elektrifikasi untuk meningkatkan kapasitas produksi dan efisiensi. Kami tak sekedar mengeksplorasi, tapi juga peduli pada masa depan planet bumi. Kami persembahkan sebuah warisan energi tanpa henti untuk negeri ini.
Setiap hari kita butuh energi. Energi yang menggerakkan kita, energi yang menghasilkan kebaikan, energi untuk terus berkarya dan berinovasi. Dengan bertumbuhnya kebutuhan energi Indonesia, ExxonMobil mendukung Indonesia untuk memaksimalkan produksi energi dan membangkitkan pertumbuhan ekonomi. Kami memproduksi energi dan mengantarkannya ke berbagai penjuru negeri. ExxonMobil bangga menjadi mitra Indonesia. Bersama Indonesia, kita mengembangkan minyak dan gas bumi dan berkontribusi kepada perkembangan negeri selama lebih dari 124 tahun. Pada tahun 2001, kami berhasil menemukan cadangan minyak di lapangan Banyu Urip dan ditunjuk sebagai operator blok cepu di bawah pelaksanaan pengelolaan K3S oleh SKK Migas. Hingga tahun 2022, Blok Cepu telah menghasilkan produksi kumulatif lebih dari 550 juta barel. Saat ini, Blok Cepu menjadi salah satu produsen minyak terbesar di Indonesia. Ini adalah perwujudan komitmen kami, guna memenuhi kebutuhan energi nasional dari sektor hulu migas. ExxonMobil juga hadir melumasi mobilitas masyarakat Indonesia dengan menyediakan berbagai produk seperti BBM berkualitas tinggi, produk pelumas, dan petrokimia berkualitas yang bermanfaat bagi kehidupan kita setiap hari. Tidak hanya itu, ExxonMobil juga mendukung program pemberdayaan masyarakat yang berfokus pada kesehatan, pendidikan, dan pengembangan ekonomi. Program kesehatan ExxonMobil dilandasi keyakinan bahwa kesehatan yang baik dapat membuka peluang, memunculkan prestasi, dan tumbuh kembang yang optimal. Selain itu, kami percaya pendidikan merupakan penggerak kemajuan bangsa. Kami terus mendukung program pendidikan yang membantu efektivitas proses belajar mengajar. Program pendidikan kami menyentuh para guru sekaligus peserta didik. Di bidang pengembangan ekonomi, berbagai program berfokus pada peningkatan kesejahteraan masyarakat. Di antaranya, kami mengembangkan program biogas sebagai energi alternatif guna mewujudkan desa mandiri energi. Efek berganda program ini bermanfaat bagi perekonomian keluarga. ExxonMobil di Indonesia berkomitmen untuk terus mendukung pertumbuhan ekonomi Indonesia dan tercapainya masa depan rendah karbon di Indonesia, dan juga turut berkontribusi langsung bagi masyarakat Indonesia. Bersama, kita bisa wujudkan masa depan yang lebih cerah dan beragam inovasi agar kita bisa terus menikmati energi penuh harapan. Inilah energi ExxonMobil dari Indonesia untuk Indonesia.
Embracing opportunities, nurturing hopes. We are undoubtedly part of it. Managing all the untapped potentials, preserving them and turning them into compounded effects as a heritage for the future. We are an inseparable part of this country, Indonesia. A nation built on noble culture and the spirit of mutual cooperation. Values having led us, Energi Mega Persada, or EMP, to become one of the leading and largest public companies in the upstream oil and gas industry in Indonesia. With the expertise we possess, coupled with innovative application of modern technology, EMP is now a primary supplier of the national energy needs, especially in Java, Sumatra, and Sulawesi. Starting our business over 2 decades ago, the pace of EMP has been unstoppable, successfully managing 13 exploration and production operational areas. One of them is located in Mozambique, South Africa, and the other 12 are in Indonesia.